Assalamu alaikum. Myself Zahida Azmat. I am from BS Chemistry Department, studied at University of Management and Technology. Today my experimental title is the electrochemical sensor fabrication and calibration for heavy metals, ions and nitride detection by cyclic volumetry, DPV or SWV, EIS electrode modification, carbon paste or screen printed electrodes. It describes a lab experiment for making and testing an electrochemical sensor that can detect things like heavy metals like lead, cadmium or nitrates in water. The experiments is about or the goal of this experiments to build a special electrode like sensors and check how well it works by drawing a calibration curve and finding two important values. The first one is the limit of detection, which is the smallest amount of this substance the sensor can notice. The second one is the limit of quantification, the smallest amount it can measure accurately. The experiment also tells how selective the sensor is, whether it gets confused by other substances, and tries it on real industrial wastewater. The materials for this experiment we need a carbon paste electrode or a screen printed electrode, a modifier like graphene oxide or metal nanoparticles to improve the electrode. The substance we want to detect like cadmium and mercury are nitrides. A supporting electrode like phosphate buffer is also used. Common ions that might interfere like sodium ions, potassium ions and chloride ions. An industrial wastewater sample for real-world testing is also required. Equipments are potentiostat, galvanostat, and an electrochemical cell, which is the reference encounter and working electrode. After this, we move towards its procedure. Electrode preparation. The first step is the electrode preparation. In this we clean the electrode, polish a glassy carbon electrode with alumina slurry and rinse with distilled water, or just rinse a screen printed electrode gently. The second one is prepare modifier suspension. Mix the modifier with the solvent like 1 mg modifier in 1 ml ethanol plus 0.1% nepheone and sonicate for 15 to 20 minutes to make it uniform. Drop cost modifier. Drop cost modifier use a micropipette to put 5 to 10 microliter of the modifier solution onto the electrode surface and let it dry in air or an oven 40 to 60 degrees Celsius for 30 minutes. The step 2 is involved electrochemical characterization. Technique use are CV cyclic volumetry, DPV or SWV for making a calibration line and EIS impedance spectroscopy. Set up a 3 electrode system. The modifier electrode working for a reference electrode and a counter electrode. The liquid used for testing is usually phosphate buffer or potassium chloride. Calibration curve. Calibration curve makes solution with known amounts of the substance we want to detect. We run DPV or SWV test on each solution and record the peak current and plot a graph of current versus concentration. Limit of detection and limit of quantification. Limit of detection is equal 3 multiply sigma over slope, the smallest amount we can detect. Limit of quantification is equal 10 multiply sigma over slope, the smallest amount we can measure accurately. Sigma is the standard deviation of the blank or background measurements. Selectivity study is to mix the target substance with other common ions like sodium ions that might interfere. Check if the electrode's signal change compared to the pure target substance. It decides if the electrode is selective, only respond to the target. Now we discuss about the reproducibility. It repeats the whole experiment multiple times to see if results are consistent. Simple explanation of the steps is with repeat measurements. Run the same test many times with the same electrode or use several identical electrodes. Then calculate the relative standard deviation to see how consistent the results are. Real sample testing is to collect and filter industrial wastewater, optionally add a known amount of the chemical we want to detect, measure the sample with the sensor, use a calibration graph to find the chemical's concentration. If we spike the sample, calculate the percent recovery, how much of the added chemical we actually detected. After this, we can move towards the observations. Observations for electrochemical sensor fabrication and calibrations are here. The first is the electrode surface appearance. Look at the electrode after we put the modifier on it. Note any color or texture change and check if the coating is even. The second observation is cyclic volumetry. In this we record the peak currents, see the shape and position of the peaks and any shift compared to a plain electrode. Third is the differential pulse volumetry. In this we note the peak current at each concentration. Check if the current rises when we increase the analyte amount and compare with a blank no analyte solution. The fourth is the calibration curve. Plot current versus concentration to get a straight line. Limit of detection and limit of quantification uses the noise from a blank measurement and its standard deviation to find the smallest amount we can detect and reliably measure. After this, we can study about the selectivity or interference study. It is a test if other chemicals change the sensor's signals or create extra peaks, showing whether the sensor picks up only the target analyte. After it, we study about the reproducibility. It checks the RST percent for repeated tests to see how stable the sensor is and whether the signal drift over time. Real sample test industrial wastewater. Industrial wastewater. In this we can study about the peak of sample solution, calculate concentration from calibration curve, and recovery if it spikes. The results of electrochemical sensor fabrication and calibration. The first is the successful electrode modification. The second is the cyclic volumetry. Third is the calibration curve and limit of detection and limit of quantification. Fifth is the selectivity or interference study, reproducibility and real sample analysis. After this, we can study about the deliverables. Deliverables of this experiment includes a calibration plot, graph with linear range and R-square value, calculation for LOD and LOQ. EIS Nyquistic plot is optional, a bar chart showing interference effect, a table of real sample recovery results, a conclusion summarizing the sensor's performance, sensitivity, stability, reproducibility, and selectivity. In simple terms, the team built a sensor that can accurately and reliably detect specific chemicals in wastewater, proved it works well in lab tests and real samples, and will hand over graphs and data that show how good the sensor is. That's all of my side. I hope you all understand this experiment. If anybody have a question, you can ask easily in comments. Thank you so much for watching my video. Thank you.